Hello dear students, now we are going to derive an expression for magnetic field due to a long straight current carrying wire, okay, using Ampere circuital law. This derivation is given in NCERT. So we will consider a very long straight conductor, say this is of infinite length, okay. Let us suppose that, say some current I is flowing through the wire. I is the current flowing through the wire. Now, let us suppose that we have to calculate magnetic field at a point P at a radial distance r from the wire. So we are trying to calculate magnetic field at point P at a radial distance r. So to calculate magnetic field at that point P, we have to consider an Amperian loop. We have to consider one Amperian loop such that that loop passes through the point where we are calculating magnetic field. Now we know that we are using this right hand rule. If current is going in this direction, magnetic field produced at point P will be inwards. Magnetic field produced at point P will be inwards. And also here, okay, if you consider one element, okay, that dl will also be inwards. dl is inwards, and also magnetic field at that point also will be inwards. Okay. Now, what is Ampere circuital law? Ampere circuital law says that line integral, okay, concentrate, line integral of magnetic field, okay, around a closed path is equal to mu naught times the net current passing through the loop. Okay. Since RHS is scalar, we are writing dot product here. Line integral of magnetic field is equal to mu naught into I. Now, what is B dot dl? B dot dl means B dl cos theta. So, I will write B dot dl is equal to B into dl into cos theta. Okay, theta is the angle between magnetic field and dl. Since magnetic field and dl both are acting inwards, okay, angle between them will be 0, okay, and cos 0 will be equal to 1. So, we will get it is integration of B into dl is equal to mu naught into, what is the net current passing through the loop? Net current is I, okay. And since at all the points on this Amperian loop, since all those points are at an equal distance from the wire, because this is the wire and Amperian loop is like this, all the points on the Amperian loop are at an equal distance from the wire, magnitude of the magnetic field at all points is same. So B is constant. You can take it outside. You can write this as B into integral of dl is equal to mu naught into I. And one more thing that we know is, if you integrate all those dl's, here we have considered a small element dl. If you add all those dl's, okay, what do we get? We get circumference of the circle. So therefore we get B into 2 pi r is equal to mu naught into I, or this implies magnetic field B is equal to mu naught I divided by 2 pi r. For a given conductor carrying some constant current I, magnetic field due to a straight wire is inversely proportional to distance. That means if you plot a graph of magnetic field versus distance, so you will get some rectangular hyperbola, okay. So magnetic field due to infinite wire or long straight current carrying wire using Ampere circuital law, the expression is mu naught I divided by 2 pi r. Hope you understood this. Thank you very much.